So what I'm going to show today is just a very, very simple web-based data viewer for HistFactory workspaces in JSON format. So part of the goal for this is just to try to create a simple tool and to solicit feedback from people about what they would like to see. So this is just it's a basic web-based tool. It's online at HEPExplorer.net, and it allows you to visualize histograms into to view different types of plots. So the part of the goal of this is just, I mean, you could do all of this in IHF, but the goal was to provide something that's simple and web-based, and also when you upload a workspace and create a new visualization, it gives you a link that you can share via URL. So we were hoping that it could uh, allow sort of an easier method of communication. Here's a list of some of the features. Basically, right now, just histograms and pull plots. And part of the potential value is that you can interactively interact with the model parameters and perform fits. So we're hoping it would allow you to get sort of a little bit better feel of how the different parameters interact. There's a mechanism where you can lock selected parameters when you do a fit, so you can have a little bit more control over the set of parameters that you're working with. And it allows you to sort the model parameters by name or by importance. Some of the models have dozens or hundreds of parameters, so it can be a little bit overwhelming. And then lastly, it lets you compare different channels side by side to get kind of a view of how they differ. So to get started, let me just kind of walk you through what it looks like to use this application. When you start, you basically just upload a workspace JSON file and then optionally a patch set file. Alternatively, if you have a URL to a HEP data workspace JSON file, you can just put the URL in. You know, some number of the HEP data records are workspace JSON files. I'm not sure what the percentage is. Right now, it only works with the JSONs rather than like some of the archives are tar archives and other forms of data which will not work. Here's just an overview of the user interface. So you have a left sidebar with a set of panels. Right now we have your patches, your channels, and then the list of parameters. On the top bar, we have a set of buttons for kind of your most common actions. Probably the most important of which is to perform a fit. And when you perform a fit, it will adjust all of the parameters. So there's a button for resetting the parameters to their original state. And then there's a button for downloading the resulting histogram in PDF format. And then in the main bar, you will see one or more plots. If there's many plots, it will show them slide sort of 2 by 2 is a list. So here's an example of comparing two channels side by side. If there's more than two, it'll show them in two columns in a scrollable list, so you can show quite a few different channels together. Another option is at the top, you can select the type of plot you'd like. So you can toggle right now between histograms and pole plots. There may be other types of plots that we may add. We're looking at that. So sort of the normal method of operation that we were anticipating is that you would select the parameters that you're interested in viewing, and you would perform a fit, and it will adjust all of these different sliders as it performs the fit. And then you can lock different ones if you have an idea of what values you would like, and then perform another fit with those parameters locked. Yeah, so the app is responsive, so it runs fine on whatever device. So we were hoping that that would make it a little bit would encourage adoption. Then these are some ideas for next steps. We're right now we're working on a method for combining multiple workspaces and resolving name conflicts in the process. And we're looking at some of these other plot types. I would be interested to hear people's feedback on what which of these may have value. We've set up a couple different means of communication. There's a Slack channel specifically for this viewer. Alternatively, you could email me, and there's also a contact form on itself. And I thought I could show an example of the application in use. So here's let's see, here's a simple multi-channel workspace. So you could see the two histograms side by side, and then so the way that you would use this is you could see that how decent the fit is down here. So you would then perform a fit, and you can see when the fit is improved, or when you adjust these parameters, you can see when how the fit improves or gets worse. So so you can see the list of parameters here. You can sort them by this little indicator is a measure of an estimation of the impact of that particular parameter. So normally you would sort by that or sort by name. And so yeah, so I would like to open it up for some discussion about next steps where you might like to see this go in terms of future improvements, or maybe some discussion about how this relates in sort of the larger ecosystem, because I know that there are other viewers and other applications that people are using. So I'm quite eager to get some feedback.
Yeah, thanks very much for this presentation, Abe, and for kind of introducing the Explorer. Maybe let's go to Zoom first and see if we have questions. I see we have some hands in the room as well, but okay, so I don't see any hands raised on Zoom, but I saw that Karsten had a hand. So Karsten?
Yeah, thanks a lot. Yeah, this looks really amazing. I think my main question is how tight this actually is to HistFactory, because in general, having a nice viewer for statistical models is super cool. And of course, there's quite a few models out there that are not pure HistFactory, or maybe a HistFactory with a bit of added sugar about it, things like regularization terms or reparameterizations with some analytical formulae. So how extensible is this viewer potentially?
Yeah, I mean, it's right now it's basically tied to HistFactory because of the HistFactory JSON format. It could be extended, I suppose. I think part of the goal was to make it as simple to use as possible, and sometimes the more you generalize things, the more complicated they get. So I'm not sure if we could extend it in a way that would sort of retain the ease of use or not. I guess we'd have to.
I'm of course mostly thinking about this in the context of what we just presented in HS3. So if we were going for, let's say, a model that is not quite HistFactory, but HistFactory plus a little bit, or maybe let's say even an analytical model that is just a one-dimensional function with a few data points, provided that I would hand you a JSON file with some reasonably specific description of what should happen.
Right.
How difficult would it be for you to extend this viewer?
Yeah, I mean those sound like those would be relatively straightforward sort of ways to interpret the data. So I think that would be doable.
Abe, correct me if I'm wrong, but this is using cabinetry under the hood, correct?
Yes, that's right.
Yeah, so I think the current limitation is, since that's using cabinetry and PyHF needs to finish an implementation of HS3 before this would be able to then do that. But as soon as that's done, then I think it would be probably a much more reasonable lift to then extend it to then look at possibly supporting other backends. Sabina, I see that you have your hand raised, but if you don't mind, I'm gonna use chair privileges to kind of inject a question comments to kind of piggyback off of Karsten's, which is, so Abe, well, you and I have talked about this before. I actually have failed to ask, I think this is like a app that's running, I forget if this is running on AWS or DigitalOcean, but this is running on some web service on a server, right?
Yes, that's right. It was running on Linode, and I just moved it over to Google Cloud Platform. But we have also tried running it on an Olvi GPU cluster with 8 A100 GPUs, and there in our initial test there wasn't a huge speed improvement, so I think we may have some work to do to take advantage of the GPUs. But if that's something that's of interest for some of the larger data sets, we could make that available. One of the limitations with the GPU machine is that it's not public facing, so you have to set up an SSH tunnel to get into it, which limits its utility somewhat, but that would be something we could explore also.
Yeah, so I guess along those lines, I don't know, this app is using cabinetry and PyHF under the hood, but I don't actually know how much, I'm assuming you have to run a web server and some additional things, but is this open source? So if people wanted to try and deploy this on their own hardware to try and do visualizations, or even on their own laptop, is that something that's feasible? Or I guess I don't know how much stuff that you actually had to put into the either the Docker, the Linux container image, or like the server that you're actually deploying this on.
Yeah, yeah, I should have mentioned that. That's a really good point. It is fully open source. There's a repo, and the installation is pretty basic as long as you have the PyHF and cabinetry dependencies installed. Basically, you just need to install the dependencies for the Flask. It's the Flask backend server, and then you can run it on your own machine. It's just a small number of steps. It's very simple to deploy.
Cool. Could you, if it's open source, could you also on your slide someplace like put the repo so that yeah, physicists love to hack, so if we can go poke at it, that'd be fun. I see that Sabina has also patiently been waiting with her her hand raised to ask a question, so please go ahead.
Yeah, thanks. So it really looks like an awesome tool, so I'm really nice, excited to try it out afterwards. My question is, to what I mean, it's already super useful to be able to inspect the model this way, but going beyond like this cabinetary type inspection, can one do actually like say you use a particular patch set and get the likelihood as a function of the counts in a specific signal region or some such functionality? Is that there?
I don't really have a means right now of exploring the individual patch set contributions. I guess I'd have to understand a little bit better how that would be done. Like if I could see how that could be done sort of through PyHF, then whatever we could do through PyHF we could sort of automate into this tool. So I guess I would have to understand the workflow a little bit better.
I mean, when you run PyHF on a particular with a particular signal patch,
okay,
you get out the expected and observed likelihood,
yes,
or CLS value, or whatever you ask for.
Okay.
Is there a way to visualize that in this tool?
Oh, there isn't, I guess. What do people currently do to perform that type of visualization?
You're looking for a scan over patch sets, essentially? Like a likelihood scan over patch sets?
No, not necessarily, but like say, even if I don't have a patch set, if I change the signal count in a specific signal region, it will give me a different expected and observed likelihood.
Sure.
Or a limit on the mu. Can this be visualized in this tool?
I mean, I think conceptually producing that data is not difficult with PyHF, but I'm assuming, I mean, if your question is about like how to get the number out, that's straightforward, but I guess this interface doesn't have such...
How to get the number from just running PyHF is easy. But
yeah,
to do a visualization of how the modification of some counts actually affects the likelihood could be interesting in this context of visualization tool.
Yeah, so I don't think I've actually seen this specific thing of like likelihood versus number of events. I'm not sure I've seen that before.
Yeah, I don't think I have either.
It doesn't strike me as a common plot, so maybe that's why I was confused.
What do you mean with them? Like, I think maybe I'm misunderstanding Sabina some level, but you're just talking about just sort of patch set level, like you ignore any sort of background model and you want to kind of explore how the patch set will be changing some arbitrary background, right? Sabine style, what you're looking for is just something more about, you want to be able to have, if you have a patch set in your background and you patch and you generate, 50 or 60 signal workspaces, and you want to kind of explore differences across all of them. Sabine, go ahead.
I didn't understand that the second part of your comment or question, but
Oh no, it's just going
forget about the patch sets. Forget about the patch sets. If I have a background only model, and I want to I just change the counts in different regions, is it possible to directly visualize the outcome of the statistical evaluation?
Oh.
You just change the count of the data you're fitting to, or of the model itself?
Of the counts I'm fitting to.
Okay, so what you're asking for is essentially a field in this interface where you can modify the data counts. I think.
Yeah.
Yeah.
Yeah, that should be the easiest
And
part, right?
then plots this, for example.
Yeah, that should be, I mean, not, I think that should be relatively doable, like easy to do, because there you're really just changing a number. So I think that should be, I think that's something we can explore, but yeah,
I mean,
maybe
technically it should be easy to do. It's just running pyhf in the background, but I was just wondering whether you've foreseen such a functionality, or you want to really have this just for inspection of the content of the model.
Yeah. Like Alex mentioned, I think that for some of us that's not as common of something that we would be doing, but I think that's a reasonable thing to want to explore. So maybe Sabina, you can be the first to email Abe and maybe put like me and the rest of the pyhf developers in CC, and we can try and play with this.
Okay.
It'd be super. Thank you.
Yeah.